We just wanted to start with appreciation and gratitude for everybody that is here today, especially for Tom and his beautiful wife Pamela for coming all the way from Alabama, and for all of you for coming all the way from your homes and being here. I know quite a few of you, and I also see a lot of new faces, and I'm fortunate and grateful to be able to have this opportunity to connect with so many wonderful, loving, beautiful people. I know that Tom has that effect where he's able to attract really good-hearted souls. And so I'm very, very humbled and grateful to be a part of this. What we're going to do is we're going to start with Tom giving an update and an overview. I just want to see who all is here. So can we just get a show of hands for those who are familiar with MBT, are quite familiar with it? So quite a few of us, okay. Is anybody new to MBT and Tom's work? Okay, so the majority of people are quite familiar. So we'll give a pretty, a brief overview of MBT, Tom will do, and then it'll be a quick update of what's going on, and then we'll just open it up to questions and answers. And then we'll jump into the afternoon session, which is evidential experiential exercises. So we'll be doing some remote viewing and some energy healing, and after that we'll break again and we'll open it to questions and answers. So without any further ado, I'd like to welcome Mr. Tom Campbell.
Thank you very much for coming here and for wanting to listen and hear what it is I have to say. It looked like there was only maybe about 10% who needed kind of a catch-up or backup. Is that true? Everybody who'd like a little backup material, a little introduction to what's going on, raise your hand. Oh, well, that's a few more. Okay. I thought maybe we didn't get them all first time. Well, we'll do that first, and then I'll kind of catch you up on what's going on in the world and with the experiments and that sort of thing for those of you who are keeping up with that. So, where do we begin? I'm a physicist. I'm a kind of an odd physicist, I guess, because I had two careers, and they both started about the same time. I got out of graduate school and took my first job doing physics, and within months, I took my first job doing consciousness research. That was with Bob Monroe. So within a few months of each other, two careers started at the same time. Now, the physics career I worked at a little more than 40 hours a week. And the conscious research career, I worked about 15 to 20 hours a week. So those were pretty long weeks if you count them both together. But fortunately, the conscious research work actually gave more energy than it took. So all that worked out. I started doing this conscious research with Bob Monroe at Whistlefield Farms. That was before there was a Monroe Institute. Bob was probably in his early 50s at the time and wanted to be legitimate. He wanted to be taken seriously. He had had out-of-body experiences. He was a corporate executive. He owned his own company, which was a cable company in Charlottesville, Virginia. He was wealthy, lived on a magnificent Virginia estate with, horses running in the fields, whitewashed board fence, the standard epitome of a Virginia gentleman. And he wanted to put his experiences kind of on the scientific map. So he built a lab and was looking for people to help him work it. I happened to be there at just that time that he was looking. So myself and a friend of mine who was an electrical engineer, we both worked at the same place. We began to come out to see Bob Monroe 15 to 20 hours a week. And the deal was that he would teach us what he knew, that is how to get out into the larger consciousness system, so it would be personal experience for us, not just reading about it or listening to Bob tell us about it. It had to be our experience, otherwise it wouldn't be real. So within a few, well, I shouldn't say a few months, within a year or so, Bob had successfully taught us how to get out into this larger consciousness system, to experience reality beyond the reality that is defined by this physical universe. And Dennis and I were both kind of hard-headed techies, so we really needed proof. We really needed to find out, was this real or was it just some trick of our mind that was making this up? So that was our mission for the first year and a half, was to convince ourselves that this was real and not just an imaginative thing. And we did evidential things in order to develop that confidence or that proof. We did remote viewing, we did healing, we tried to read the local newspaper's headlines a week before, the headline was published. We read numbers on blackboards that were, put up where we couldn't see them. We did lots and lots of evidential experiments, because those are the only kind of experiments that will help you understand whether or not it's real. And that's why we're going to do some of this afternoon, or in the last half of this talk, because I tell everybody that if it's not your experience, it's not your truth. Okay? All of reality is subjective. That part of reality that has a very low uncertainty approximates being objective. But there really is no objective reality. If you measure something in the physical world, you will get to a point where you have to have a statistical description. It's this long, plus or minus this much. What that plus or minus means is that you really don't know how long it is. Could be this much and could be that much. Okay, so we're never sure. There's nothing that's absolutely objective. But when you're measuring things like how long they are, how much they weigh, or that sort of thing, there's very little uncertainty there. That plus or minus can get to be very, very small if you have very, very accurate measuring equipment. But it never goes to zero. Okay. So that's that part of the subjective reality that has very low uncertainty. That is what we call the physical objective world. And it's just an approximation. So we have this bigger reality that is subjective. And it takes in a lot of things. It takes in everything as far as we're concerned in our minds. And there's just this piece of it, this smaller piece of it, where the uncertainty is real small. And that's the objective world that we live in. That's the objective world of science. So science limits itself to studying the almost objective reality. That's what they do. Anything outside of that is not science. That's the viewpoint that scientists have. Well, if you think about that for a minute, you realize that's pretty lopsided. Think about in your own life, what is important in your life? What's been significant in your life? What really makes the difference in your life? And you will probably not find it's anything objective. The objective world is the stuff. It's the setting on the stage. It's the props. The real meat, the real meaning, significance of your life is all on the subjective side. It's about love. It's about caring. It's about fairness. It's about growth. It's about perspective. All of these things are subjective. So we have this large reality. It's mostly subjective. And almost all the important part is clearly subjective. And then there's just one little piece over here that's approximately objective, and that's what science does. Well, I was caught between two worlds. I'm a physicist, and then I was a consciousness researcher. One was extreme in the objective world, the other was pretty extreme in the subjective world. And what I wanted to do was to bring those together so that they weren't one's over here and one's over there. You can be here or you can be there, but the two of them just don't connect. That seemed to me to be a failure of understanding, that they didn't connect. They should connect. You've got this big reality, and there's just a subset of it that's objective. It all should flow one into the other. So I took it upon myself as the resident physicist in the little group of people around Bob Monroe to try to figure out how it all worked. How did the subjective world work? How did this out-of-body world work? How could you start with consciousness and end up with physics? They're all connected together. There should be a path that leads from one to the other. They should all be connected. And if you go back 300 years, you find they were connected. That's why physicists get PhDs. That's a doctor of philosophy, not a doctor of science, but a doctor of philosophy. Some 100 years ago, science and philosophy were all part of the same thing. It was just a branch of natural philosophy. And metaphysics was pretty much an important part of most people's lives. But that changed once science began to take root and grow. The philosophical part, the metaphysical part, the subjective part got ignored, and the objective part was the only thing that was real. Everything else was imaginary. So that's kind of was my world when I started with Bob Monroe. Bob was a good teacher, and he taught me to be able to get into an altered state, get into some other reality, which we'll just kind of leave it at some other reality because there was really no definition about exactly what it was or where it was or anything about it. But I could get into this space very precisely. I could repeat getting into the same space in exactly the same way. So if you can do that consistently, you can start doing science in the non-physical. The non-physical being everything except what we call this subset that's almost objective. So I did that, and I found that if I were healing or remote viewing or doing other things where I could check and see if I actually was getting the right information, if it was outside of me rather than inside of me being made up by my imagination, that I could do experiments there where I would, I work a process, say in remote viewing, and then I would change a variable, and then I'd do it again, maybe 100 times. And if I didn't change variables, I would get the same result every time. So then I would change another variable and do it another 100 times, and so on, until I eventually came to understand that there was a set of facts, things that I knew from experience that were true in the area of non-physical. So now my job was I had this set of facts that were in the consciousness realm or the non-physical realm, and I had this set of facts that was part of my physics background, and I just needed to come up with an idea, a theory, something that was simple that would connect all of those dots and all of those facts with one understanding. So that's what I set out to do. And it took me about 35 years to draw a line through all those points. It wasn't a very fast process. But I did eventually do it, and one of the big breakthroughs was that I understood that not only that all of reality was subjective, but that two things about consciousness, two things about this other non-physical world, which I'll just now call the world of consciousness. And one of those was that consciousness was fundamental. And what happened in the physical world was derived from consciousness. Consciousness was the fundamental thing. The physical world was a subset of that, because I could do things with my consciousness that would change things in the physical world. So the physical world wasn't the leader here. The physical world was another step down in the flow of logic. The change in consciousness was fundamental. I also realized that consciousness is just information. When you are in another reality frame, you get different information than you are when you're in this reality frame. It's just information. And when you think about that, that should make sense to you, because what are you conscious of? You're conscious of all of the things that your five senses pick up. You're conscious of what you hear, what you see, what you touch, what you smell, what you taste. That's it. If you turn all of those data streams off, turn off your sense data, what are you aware of? What are you conscious of? Only one thing, and that is that you exist. That's a state I call point consciousness, where you become aware that what you are is a point of consciousness floating in an infinite void. That's your perception. It's kind of the Descartes moment, right? I am. I'm here. I'm thinking. Therefore, I must exist. And that's point consciousness. Okay. So consciousness is information. It's existence and information. Our reality, all reality, is made of information, whether it's non-physical reality or whether it's physical reality. It's just information. So now think of your reality being defined by a data stream. You get data, you interpret the data, that defines your reality. So you can do that with a data stream that defines this physical universe, and now you're in the physical universe reality. Or you can get a data stream that defines some other reality, maybe the dream reality. So you're dreaming, you get a different data stream. Realities are defined by rule sets. Rule sets define context, what things mean, relationships between things. Okay. If you don't have rules, you don't have any context for how anything relates to anything else. So these realities that are information-based are also rule set-based. That's what makes the information make sense. With no rules, information is just information. It doesn't actually pull together to have content until there are rules to define the content. Okay, so we can be in various realities. Realities are really information. Realities are subjective, and a subset of our reality is approximately objective. Okay, because we can be in multiple realities, we can call ourselves multidimensional beings if these different realities are called different dimensions. And that's just a metaphor. Don't think dimensional in terms of, 3 dimensions, 4 dimensions. Those are geometric dimensions. Those are spatial dimensions. I'm not talking about spatial dimensions. I'm just talking about someplace else. And I'm calling that a dimension. Okay, someplace else that's different from this place. Okay, so all of our reality is subjective. Now, if you're getting a data stream that defines a reality, we call that a virtual reality, an information-based reality, or a simulation. Those are all the same thing. The data stream has to come from whatever it is that is computing that reality. Right, so now I'm going to slip into some computer science metaphors, but these are all metaphors. So information needs rules to create structure, context, and you have a system of rules that defines how the data stream needs to be interpreted, and we'll call that a reality frame. There's lots of these different reality frames. You know this one called the physical universe, and you know the one that you dream in. It's a different reality frame. And you may do lucid dreaming or out of body or daydreaming or any number of other things. You may have a near-death experience. All of these things put you in, or you experience some other reality other than this one. You can even take a psychotropic drug, and it will cause you to experience a reality that's different than this one. What defines the nature of that reality is its rule sets. But if it is an experiential reality, that means a reality in which you can experience, then that's a reality that has a data stream and rules, and that is called a virtual reality. There's only one thing that is fundamental, and that's consciousness. Everything else that you can experience is a virtual reality. Okay, so let's think, change gears a little here, and we'll see, what does this mean to us? Okay, I've kind of laid out basic fundamental theory of the nature of reality, but what does that mean to us? Well, virtual realities have their own logic. And all virtual realities have the same logic. It's just applied differently, but it's the same basic logic. When you're in a virtual reality, the source of that virtual reality, the computer that computes that virtual reality, cannot be inside the virtual reality it computes. Right? Trivial logic, right? Third grade logic. The virtual reality that the computer is computing can't contain the computer that's computing it. In other words, if you're in The Sims and you want to find where The Sims, how The Sims is created, where that data is coming from, you won't find the computer that's computing The Sims inside The Sims reality. All right. The second thing is that there is always a player. A virtual reality produces avatars, just a computer-generated figure that represents the data stream. Okay, you have an avatar, and that avatar's job is really to constrain what the avatar can do by the rule set. The avatar is computed according to the rule set. So if you have a rule set that says this avatar can fly, then it can fly. Or if the rule set says that avatar can't fly, then it can't. So what happens within a virtual reality depends on what the rule set is and what the rule set allows. That's why it's the rules. Okay, so the the characters inside the virtual reality are only skin deep, if you like. Your Sims character doesn't have lungs and hearts and intestines and digestive system. It only has what you can see, what you can sense. Because the data stream is only going to tell you what your avatar is sensing with its, say, 5 senses, if it's going to be similar to us. So you know what your avatar sees, you know what he hears, you know what he feels, you know what he tastes and smells if it's a really good virtual reality. But that's it. You don't know what's under the hoods. You don't know about his insides or any of that. None of that's computed because none of that's necessary. The computer doesn't compute anything that isn't necessary. So that's the way avatars are. They're just shells. They're just visual representations of what the rule set allows the avatar to do and the interaction between avatars if it's a multiplayer game. So where's the player? Where's the player that's actually making choices for that avatar? If the avatar is just an image, then the avatar doesn't make choices. It's just a shell. It's just a eye candy, a pretty picture. Well, the player makes the choices. So you have a server or a computer creates the images. You have a player that tells the images what to do. The player and the computer have to talk to each other. Really, that's all that's going on. The player says, okay, I want my avatar to stand up and dance. Sends that to the computer. The computer draws a picture of the avatar standing up and dancing and computes all the consequences of that because it's a multiplayer game and sends that data to the player who gets the data, sees these avatars dancing, and then the player decides to say something else. And the avatar will do something else. So what's really going on here is a conversation between a player and a computer. And both of those things have to be non-physical from the perspective of the virtual reality. See, we said the computer can't be in the virtual reality, and from the perspective of that virtual reality, that computer has to be somewhere else, but not in the virtual reality. The player has to be somewhere else, not in the virtual reality. And the player and the computer have to be in the same reality because they're talking to each other constantly. So what does that mean to us? That means that this body is an avatar. That I'm not the body, I'm consciousness. I'm a player, an individuated unit of consciousness that's making choices for an avatar that's being computed. Okay, so we have computers, consciousness, and then the virtual reality, the avatars. Well, because the player and the computer all have to be in the same reality frame, they're all really part of the same rules. They have to be part of the same thing, the same reality. So what we have now is consciousness, what I call the larger consciousness system. That larger consciousness system is an information system because consciousness is information. That information system can configure pieces of itself as a computer, because a computer is just an information system, and it can configure pieces of itself as players, individuated units of consciousness. So the computer, part of consciousness, can send information to the player. This is part of consciousness. That player gets that information and interprets it to be a virtual reality, just like we do. When we get the Sims, what's the data stream? The data stream is a stream of data that the server of the Sims sends to us. Well, it sends it to our computer. It sends it to our computer as an array of, let's say, 1 million dots of light. That's what your computer displays. Your computer displays pixels. And let's say there's 1 million pixels on your computer screen. So how does the computer send you a data stream? It sends you the intensity, the color, and the position of 1 million points. That's it. And you look at that data, you look at those 1 million points of light, and you turn that into rivers and streams and cars and buses and houses and people with heads and arms and legs. You turn it into all of that, when all it is just 1 million dots of light. You interpret the data to be the reality. All right, so that's kind of a very quick summary of who we are and what we are. And now let's do a little bit about why we are, the purpose of us. All information systems evolve or de-evolve by creating more information. If you have less information, if you are de-evolving and getting less and less information, you end up with no information system. The information system dies, disappears. Okay, how do you make information? Assume that information can be broken down into pieces, bits. If all the bits are random, there's no information. If you order the bits, that ordering creates information. Okay. Ordering is a specific thing, and that specific thing has rules. It means something. It could be a symbol for something. But even just a pattern contains information. Up, down, up, down, up. What's next? Down. How'd you know that? Because the pattern contained information. You got the information out of the pattern, and you could predict what was going to happen next because you got that information. So you see, information, order, creates information. Now in science and physics, we have a term for a measure of disorder. It's called entropy. If you take a measure of the disorder of a system, first you need a system, you look at that system, and in that whole system you say, what's the measure of disorder? It's entropy. So if you want to create more information in that system, you need to lower the entropy of the system. You need to get rid of some of that disorder and create some order. Right. So this turns into the general principle that if you're an information system, the way you evolve is to lower your entropy, create more order, create more information, create information that has more meaning, that has depth, significance. All of that is structure. The depth and the significance are also structure, also ordering. So information systems have two choices. They can live or die. They can evolve or de-evolve. Continue to de-evolve, you die. Now, consciousness information system has piece parts. It started out as a monolithic thing, but monolithic things only have so much room to grow into. There's only so many ways that a monolithic thing can configure itself before it just can't think of anything else to do. It's limited by being a monolithic thing. So consciousness got to that point, and consciousness decided that it could create more potentiality, more states in which it could move into, if it took a chunk of itself and gave that chunk free will just like it had, and interacted freely with that thing. Now, because they both have free will, how they might interact, who knows? You never know where that's going to go. Well, then you can make maybe tens of thousands or millions of these things that all interact with free will. Think of the potentiality of where that could go. Now the possibilities are huge. with all those things being independent and having free will. Now, I just threw free will in there. Suddenly we were going along and pop, there was free will. All right. You can't have consciousness without free will. Consciousness makes choices. There are no choices if there is no free will. That's what free will means. It means you're able to make choices. The opposite of free will is determinism, and there are no choices in determinism. It just is. However, it is, and no choices are ever made. So we talk about consciousness. Free will is logically necessary. Time is also logically necessary. You can't make a choice without time, because it was before you made the choice and after you made the choice. Okay. Information grows. You can't have evolution without time. Just the concept of evolution requires the concept of change. Change requires the concept of time. So time, free will, consciousness are all logically necessary for each other. Take any one of those away, the other two can't exist. The opposite to that is determinism, okay, and materialism. And if you have determinism and materialism, then you also logically must have no time. Time must be an illusion, because if you have time, you have change. If you have determinism, there's no change. You see, you have to have no time if you have determinism. You also have to have no consciousness, because consciousness makes choices. You also have to have no free will, because there are no choices. There can't be free will. So you see, the materialism, determinism is logically antithetical to consciousness, free will, time. And people routinely mix the two up. Oh, I'm deterministic about this and materialistic about that, but there's still time, and yes, consciousness exists. And if you mix those up, you're just being inconsistent, logically inconsistent. The two don't mix. Okay, so anyway, that's where the free will came from. I just kind of tossed it in there, but it's a property of consciousness, just as time is a property of consciousness. So if you're in that group of consciousness, free will, and time, then you would say that materialism is an illusion, and that determinism is an illusion, doesn't really exist. And if you're in that clump of determinism and materialism, you'd say that time is an illusion. Consciousness is an illusion. Okay, so that's where the free will, I didn't just throw that in there as a trick. It really belongs in there. It has to be in there. It's logically bound up together with consciousness. All right, so let's see, where were we? We have this larger consciousness system. The larger consciousness system breaks itself up into what I call individuated units of consciousness, because now the room, the possibilities, the room for expansion and growth is immense again. And what we have in this groups of pieces of consciousness is a social system. Consciousness makes choices. That means it interacts. Pretty much it communicates. Okay, so it transmits and it receives. That's what consciousness does. Well, when you have a social system, there is an optimal way that members of a social system can interact with each other that lowers entropy. That's what I mean by optimal way. It's an optimal entropy reduction. Okay? And there's only one way to do that. In a social system, the optimal entropy reduction, or the optimal growth, evolution of the consciousness system, can only happen if all the pieces cooperate. If they don't cooperate, you have chaos. chaos is not low entropy. Chaos is high entropy. Right? It's disorder. So cooperation requires caring. Everybody doesn't randomly cooperate. Cooperation requires caring. Caring requires it to be about other, not just about self.
I care about you and I want to bring you some water.
All right, thank you. So now we see that if we have an information system, and this information system wants to survive and grow and evolve, it has to lower its entropy. How does it do that? By interacting with all the pieces with caring about other. Okay, well, I call that love. Love is about other, not about self. And the opposite of love is fear. Fear is about self. Fear can only be self-centered. Even if I am afraid for you, the fear is still the I am afraid. It's still about you. So now we have the social system whose mission, whose goal, whose purpose in life is to lower its entropy, and it finds out that that is equivalent to becoming love. These individuated units of consciousness need to care about each other. Otherwise, it's suboptimal. Well, who are we? We are these individuated units of consciousness. That's who we are. We're the players in this virtual reality. We're chunks of consciousness. One last thing I want to bring into this is, where did the virtual reality come from and why? Okay, because we now have our purpose. What is our purpose? Is to care about each other, to become love. That's the purpose. That's how we, as chunks of consciousness, and the system, as the larger conscious system, evolves. So we have a mission. We have a purpose. Well, here we are, interacting with all these units of consciousness, trying to figure out that cooperation's what it's supposed to be all about. And we have to figure it out, because it only counts if we actually are love. It doesn't count if we just are acting. Acting doesn't lower entropy. Acting changes behavior, but it doesn't change what we are. You can act kind, but that's an entirely different thing than being kind. So it's not a matter of these individuated units of consciousness acting nice to each other, acting as if they cared. They have to really care. And they have to figure that out on their own. Because if somebody says, hey guys, here's the right answer to the test, everybody needs to act like they care. And then the entropy will go down. And then we'll all be fine. It doesn't work like that. You see, everybody acting nice isn't helpful. Well, it is helpful. It makes us more civilized. We enjoy it more. But it doesn't help us lower the entropy any. It just creates a very, very thin veneer of civilization on top of something that is still chaotic, still unruly, still fearful. So in order to help these individuated units of consciousness evolve, the larger conscious system understood that they needed a tighter rule set, because just communicating with each other had no teeth. There were no consequences. You could say whatever you wanted to somebody, and they could say whatever they wanted to you, and it's just, there's no consequences. Just like being in a big chat room with no rules. It's kind of hard to get any traction on choice and meaningful choice and structure like that. So the system said, what we need is another virtual reality, another reality that's information-based, just like the one they were in. That big chat room was a virtual reality. The rule set was the communication protocols. Okay, so we need a virtual reality with more rules, because more rules create more consequences. See? And the more complex your rule set is, the more complex are the interactions according to those rules. So you play a game that has very few rules, it's a very simple game. There's only very simple strategies that you can have and very simple outcomes. You play a game that has a very complex rule set, and now there's a very complex set of strategies, ways you can play, outcomes, you know, what you can do and not do. It's a whole different world. So by the structure that's given by the rule set, a tight structure creates a lot of consequences. What you do matters. What you do affects what everybody else is doing. Every choice you make affects other choice makers, and their choices affect you, because that's the way the rule set is. So it started to make a reality that had more rules than a chat room. It started with initial conditions and a rule set. That's all. Initial conditions, okay, here's what we're going to start with, and then we're going to let that change according to these rules. So there's initial conditions, rule sets all set, so then you push the run button on the computer, and it's the initial stuff starts to change according to the rules. And that's a simulation with a rule set. So in our physical universe, what was that set of initial conditions? Oh, it's a very small, tight ball of plasma, very high temperature, very high pressure, and you'll recognize that as the beginning of the Big Bang Theory. And what's the rule set? Well, that's what we call science. That's what scientists do. They dig out these rules. This is all this rule set that our reality is based on, and if you're a scientist, you want to find out what the rules are. That's what physics and chemistry and biology is doing. They're digging out the rules of the rule set. So this thing evolved. And it evolved a little ways and probably became unstable and crashed, because that's what happens when you start building computer programs for the first time. They crash a lot. So the system changes the initial conditions a little, changes the rule sets a little, and punches the run button again. And it maybe goes a little longer and then crashes. And so this happens over and over and over again by trial and error, and the rule set evolves. The initial conditions evolve, trial and error, until you get something that lasts long enough to be useful. What does useful mean? It produces a tight rule set virtual reality with consequences. Okay. Now we have a thing in physics called the Anthropic Principle, and it mystifies physicists, because what it is there's a set of constants, not a lot of them, but there's a half a dozen constants. And these constants are necessary. These are constants as far as our physical reality goes. These constants are necessary right out to the 10th decimal place. Otherwise, our physical universe would collapse, fall apart, wouldn't work. And that mystified a lot of physicists, because here are all these constants, and if in the 8th decimal place you changed it, the universe falls apart. So these constants have to all be balanced one with the other very, very precisely. And they looked at that and said, how could that just come about randomly? Because, science has everything coming together randomly. How do you get, these half a dozen constants all coming together randomly to 14 decimal places? Well, the idea was, and it's called the Anthropic Principle, that it seems like this universe was put together just for us, because it has just the right constants for us to survive here, to have been stable long enough for us to evolve here, to be such that, we could evolve and grow here. So, anthropic meaning person-centered. Well, it was like that because that's how you evolve a rule set and evolve initial conditions. You keep doing it trial and error until you finally tweak it to the point that it works. Okay, so that's our virtual reality. And in the beginning, the computer played all the characters. In computer games, that's called NPCs, non-player characters. So the computer played all the characters until it evolved enough so that there were characters making interesting choices. And when they had characters making interesting choices, individuated units of consciousness could log on and start making the choices for that character. How do they log on? Well, the system, instead of just computing all the sense data for the NPCs, it just took that sense data and started sending it to the consciousness and let the consciousness make the choices for that character. That's all that was required as far as the log-on goes. So eventually, individuated units of consciousness like us all decided to log on and make choices for these characters. Now, these characters aren't just all humans. They're dogs and cats and bumblebees and fish and all kinds of things. They're, anything that has a finite decision space, in other words, can make free will choices, even if the choices are just limited to a couple of things. If it can make a free will choice, then we'll say it's conscious. If it can't make a free will choice, if it's just algorithmic, it just does what it does because that's what DNA says it does. It's like a computer program. Then it's not conscious. Okay, and what's conscious and what's not, according to that definition, is sometimes hard to tell. Is a clam conscious? Well, I don't know. You touch its foot, when its foot's out, it'll pull it back in. But is that because it said, oh, something touched my foot. Should I pull my foot in or should I leave it out there? Oh, I think I'll leave it out there this time. If that's what's going on, then the clam's conscious. If it's just touched the foot, triggers some chemical to be released that activates the muscles that jerks the foot in, then that clam's not necessarily conscious. It's just reacting. In those kinds of systems, if the stimulus is repeated in the exact same situation, the result is repeated in the exact same situation. If we have consciousness, you can make the stimulus be the same and you'll get variations in the result because the organism has a chance to change its mind if it's conscious. All right, so now we have a virtual reality called physical universe with a planet called Earth, with simulated beings called avatars that are able to make interesting choices with individuated units of consciousness logged onto them making those choices. Okay, that's us. That's our reality. And the key point I want to make here is that we have a purpose here. We're not here just to have fun. It's not a game that you play for entertainment. It's a game you're playing for a very serious reason, and that is to become love, to learn how to care about others, to learn empathy, to learn compassion, to ask, what can I give? How can I help? Rather than, what's in it for me and what can I get? You see? So it turns out to be a model. This is a model of reality that I'm talking about. All the things that I've been telling you, all the piece parts, IUOCs, and large kind of systems, these are all metaphors. And you should never confuse reality with the model of reality. Okay. We can only make models, and that's all we can see. We can't ever see anything else. So we can make models, and we need to make models, and we need to make metaphors so that we can talk to each other. Otherwise, we can't have a conversation. So that's sort of where we are. I think I've got all the major pieces together for the newbies. Kind of brought you all up to speed. I took a little more time with it because there really was about 30, 40% of you really thought you needed some background, and it never hurts the people who've already been there a couple of times to hear it again. So let's then talk about what's going on now. Well, it turns out with this system that you can take, because consciousness is fundamental, you should be able to start with consciousness and define everything else. And as I wrote my books, I knew that that was the way it had to be. But I really didn't know how to derive physics from consciousness. But about 2 years after I'd published the books, I got some aha moments that were triggered by some things that other people said to me. And I did see how to derive physics from consciousness. It turns out that the very same principles that define consciousness can also define quantum mechanics. Not only define quantum mechanics, but make quantum mechanics an understandable, rational science, not a weird science like it is now. A science that's logical, and it can define relativity. And it can answer the big unanswered question in relativity, which is, why is the speed of light a constant? So it not only does science, but it does better science, because you're deriving the science from first principles. The science we have now isn't developed from first principles. We've come up with a fact, and that fact just came out of experiment, or first it came out of guessing. So we know the speed of light's a constant, but we have no idea why it ought to be that way. There's nothing else that has a speed that's constant. Just this one thing, and there's really no explanation for it. With quantum mechanics, the only way to do good quantum mechanics is to let go of particles and let particles be described as probability distributions. And there's no reason why particles should be best modeled with probability distributions. It's very counterintuitive. But from the viewpoint of consciousness, it's the only thing that they could be described as. Just like the only way that light could exist is the only way the virtual reality could exist is with light as a constant. So I took that knowledge and began doing physics with consciousness. And I came up with some basic theories that unified quantum mechanics and relativity, which was Einstein's toe. And that's the toe the physicists want. But it's really part of a bigger toe that has everything, all the reality, not just a little objective subset. It fits the whole thing. So then that same principles do everything. But to make the story a little shorter, I found that I could understand and give good logical reasons for all the paradoxes that were hanging out in physics at the time. And there's lots of paradoxes in physics, lots of things that physicists say, well, we know it's like this, but we have no idea why. Dozens and dozens of paradoxes. Some of them are just very simple things. Where does time come from? Where does space come from? Where does charge come from? Where does mass come from? Well, I just listed all the things that are fundamental to physics. Everything else in physics is made out of those things. So the things you start with are totally unknown, what they are, where they come from. They just seem to be. Well, that is a signature of a virtual reality. If you're an elf in World of Warcraft, where did this come from? I don't know. It just seemed to start it. Nothing. Well, that's our ball of plasma. Where did that come from? Just started from nothing. That's a signature of a virtual reality. Where did these rules come from? How do we know, what's this mass and charge, and where did all these rules come from? I don't know. See, it's the rules that define mass and charge and space. Those are defined in the rule set. But they just are because it's fundamental to the rule set. They just come out of nothing. So there's lots of paradoxes in physics, lots of effects, lots of things that science have come up with, and they just say, that's the way it is, but nobody knows why. Nobody will ever know why. It's impossible. Some things we weren't just meant to know. And that's the attitude that physics has taken. From the perspective of virtual reality, all those paradoxes meld into a logical answer. They're all there because that's the way it has to be. Speed of light's a good example. That's almost a trivial example. So it's an easy one for me to tell you. I know you're not all physicists. You know, probably most of you are, right? Yeah. But this is easy. You have a virtual reality. A virtual reality comes in discrete chunks, right? It comes down to pixels. That's what we call pixels on a screen. It comes down to a quantum of something, a smallest piece. It's a digital reality. So that smallest piece defines the resolution of the virtual reality. So you take a virtual reality like this one, and you say, what's the smallest piece of time? That's a pixel of time, if you will, or a quanta of time. Scientists call that the Planck time. And there's a quanta of space. Okay, there's some little chunk of space. They call that a Planck length. It's really a Planck volume, but they will break it down and just look at one dimension as a Planck length. Okay, those two small things define the resolution of the virtual reality. That's the grid that the virtual reality is set on. And the way a dynamic reality works is you add another delta t to the last time to get the next time. So here's the way the world is at time t, and then at time t plus delta t, you recalculate everything. And then at t plus 2 delta t, you recalculate everything. T plus 3 delta t, you see every delta t, you recalculate everything. That's how a dynamic simulation works. So what's the speed limit in a reality where you have a constraint of things have to move contiguously? You don't have things just disappearing here and reappearing someplace else. They don't just randomly teleport around. They can only move in a contiguous fashion through space. It's 1 delta x for every delta t. So you take your delta x, you divide it by your delta t, you get a speed of light. Nothing can move faster in a reality other than 1 delta x for every delta t. It's constant. It's the max speed limit. And every virtual reality, including the World of Warcraft and The Sims, have a maximum speed limit. You can't move anything through that reality any faster than one of their pixels of distance divided by one of their pixels of time. Okay, so see, that's just trivial. You see this as a virtual reality, and suddenly the speed of light being the constant is the simplest thing ever. And that's the way all the others turned out too. Really simple. And there's a thing in science that says that if it's fundamental, it has to be simple. Simplicity to the point of being elegant. That's a fundamental thing. If it's very complicated and it takes you 3 pages of equations to describe it, it's not fundamental. It still may be logical. You know, there's lots of logic trails that you can lead to things that you can calculate, but everything fundamental has to be simple. And this virtual reality idea makes science simple. Makes the unknown simple. So I have put together a set of quantum mechanics experiments. There's 5 different quantum mechanics experiments. And in these quantum mechanics experiments, I did double slit type experiments, but new versions of double slit that have never been done before. And if these work out the way that I hope they will work out, and they may not, you know, that's science. You don't know everything. You get to a point where you're kind of stuck, and you need to do an experiment to see how it really is to get unstuck. Well, that's kind of where I am. I've worked through this physics now from a virtual reality perspective, and I get to a point where I say, well, this is I have these assumptions. My assumptions are that the calculations that the system will make will be parsimonious. That means it'll be efficient programming. It's not going to do sloppy, inefficient programming. It's had a few billion years to work out the bugs. So it should be good programming. But that's an assumption. And there may be some cases where the system says, yeah, that's not the most efficient way, but it's the way I want to do it for my own reasons. In which case, then I'll get it wrong because I'm assuming that it's going to be efficient. So you see, I've gotten to some points in my derivations where I need some experiments to say it works. The system's going to do it this way rather than that way. So I don't know if those assumptions are all right, but I need to find out or I can't take the next step past that point. So these experiments are for me to learn about how the larger consciousness system renders this reality. And if they work out the way I think they will, they will produce some major miracles. The original double slit experiment produced maybe a minor miracle. What it did is that individual particles, one at a time, were fired, projected toward two slits, and because there were no other forces on them at all, Newton told us that they'll just keep traveling in a straight line because there's no other forces, and they'll land on the screen behind the slits, go through a slit, land on the screen right behind the slit. That's what they should do. They didn't. They went through the slits one at a time, and instead of making piles of particles behind each slit, these particles distributed themselves into what's called a diffraction pattern. Some of them went here, some of them went here, and there were little gaps in between. They had no particles at all, and some of them went other places, so they had this diffraction pattern, a very specific pattern. And how and why did these particles rearrange themselves in space when there were no forces to make them do that? Well, minor miracle. I call it minor because particles are really small and we really can't see them, and we don't really know what's going on, so we can say, well, somewhere down in all that haze where we can't see, something's going on and we just don't understand it. There must be some forces or something that's really doing it that are beyond our knowing. So that's a minor miracle anyway. The ones that I'm proposing would have an experimenter be able to predict how a particle is going to decay before it decays. Radioactive particles, well, when an atom decays, it's a big atom, it's complicated, it decays, it loses energy. And when it loses energy, that much energy that it loses gets spit out as a particle. That's called radiation. That's the way decay is. But that radiation, that particle that gets spit out, can be spit out in any direction, entirely random. Well, in this experimenter will be able to predict how that particle will be spit out, in what direction, before it decays. Totally impossible. So that's why I call it a miracle. When you do the impossible, it's called a miracle. The other miracle that I'd like to do is there's a little piece of glass with proper treatment with dielectrics becomes a beam splitter. And what that means is that if you have a photon, light beam, but just a photon, a particle of light coming and it hits this piece of glass, it has a 50-50 chance of transmitting through the glass or reflecting from the glass. So usually the glass is like at a 45-degree angle. So if it hits here, it bounces that way, otherwise it goes straight through. And those are called beam splitters, and they can be manufactured so that that 50-50 is very precise. Okay. And one of my experiments will predict whether that photon will transmit or reflect before the photon ever gets there. Patently impossible. Just cannot be done. It's physically impossible. So if we do the impossible with these experiments, then that's going to create some evidence that this reality is not materialistic. And the only answer, if it's not materialistic, has to be that it is information-based. There's no other rational answer. So these will give the virtual reality concept kind of an evidential boost. I mean, the double slit already gives it an evidential boost, but you can't have too many of these miracles. Eventually, scientists will be unable to just kind of stick their head in the sand and say, oh, well, it's just weird science, let's go on. So that's what I'm hoping to do. And about 2 months ago, maybe less, a month ago, I did a Kickstart crowdfunding campaign to fund this. Because as you might imagine, you can't walk into a physics department and say, I've got some experiments I'd like you to do. When could you start? That's not going to work out too well. Even though these are relatively simple and inexpensive experiments, that doesn't mean they're cheap. It just means that relative to other physics experiments, they're easy and simple. But it still takes a lot of time, money, equipment to do them. So we got $236, I think, $1,000 from crowdfunding, which is enough to get started. I don't know if it's enough to do them all, but it's enough to get started. And that's really all we need, is enough to get started. So in the next, where I am now is getting ready to send out requests for information to physics departments and particular physicists that we think might be interested, for them to tell us, how much is it going to cost and that sort of thing. So we're starting to get that done now. That will probably take 6 months or so before you get all that back, and you can say which one do we get better research for less money and so on, till we sort out the what you get for what it costs, and then we'll start the experiments. And they shouldn't take more than 2 or 3 months. Again, they're not that hard to do. So sometime between maybe 3/4 of a year to a year to a year and a half, who knows how long all this will take. I have no idea really how expensive it's going to be, but I think we have enough to get started. So that's kind of gets you up to date to where we are. So this is not, well, I should mention that. A lot of the concepts that the MBT theory, the MBT model comes up with, have been around a long time. And it wasn't because I knew about these ideas that had been around a long time and I wanted to make my theory come out the same way. I was one of these guys who did their work the wrong way around. I made my model in a vacuum because it was me and my research in the non-physical and my knowledge of the physical, and I knew I wasn't going to find a lot of stuff out there about other people having done research in the non-physical. It's like a one point. So I didn't really do the literature search first. I did it last. So I didn't really look at anybody else's viewpoint about reality or how it worked. So I made mine in a vacuum, basically, made up my own terms as I went along. And then later, I had all these people saying, you sound just like a Tibetan Buddhist. You sound just like a Kabbalist. You sound just like the Aborigines in Australia's dream world. You sound just like. So after I got lots and lots and lots of these, evidently there were a whole lot of people from a long time ago that sounded a whole lot like me, and I sounded a whole lot like them. So as it turns out, a lot of the Eastern theology and MBT is very, very close. The big difference is that Eastern theology and Western theology, Western theology is close in a lot of ways too. How much closer can you get than God is love, right? That's a statement out of Christianity. That's about as close as you can get. So in general, these ideas have been around for a long, long time. 2,400 years ago, the Buddha said, this reality is an illusion. Well, I'm saying this reality is virtual. What's the difference, right? It's the same thing. And the Buddha also said, love is the answer, and that's what I'm saying. So, and before the Buddha, there was lots of Hinduism that the Buddha branched out of. So these ideas are old. And the reason that there's so many of these different ways of looking at it, actually it's the same ideas with different metaphors, is that there is only one truth. But there's thousands and thousands of ways to approach that truth, and tens of thousands of metaphors by which you can explain that truth. So that's why you have this convergence. There's just one truth. And lots of people have been converging on it for millennia. The difference is that that religious truth that turns out to be really solid stuff, that is the way the world works, tends to be poetry. It's poetical. It needs to be interpreted. And people interpret it differently. And you really have to grow to it. You have to understand it deeply from your experience before you can interpret it right. The more you grow up, the more you look at that and you say, oh, I understand what that means now. You see, but when you're not that so grown up, it's kind of mystical looking, which is why all those people were called mystics, because most people aren't so grown up and it just didn't make any sense. The difference is that if you make a model and have metaphors based on logic instead of poetry, when you get to the end point where your model's done, you can derive science. You can derive physics. Yes, the Buddha knew it was a virtual reality, and yes, he knew love was the answer, and even Buddhism has derived a fair amount of science in some of their groups, but it doesn't really derive science in modern terminology that scientists can look at and say, yeah, oh, you think this double slit experiment will work? It doesn't derive double slit experiments. So that's the difference. Other than that, what I bring to you in a model's been around for millennia and millennia for the most part. The difference is that it can also explain science and also then unify physical and non-physical, all part of one thing. Mind and matter, all part of one thing. Normal and paranormal, it's all normal. Just different perspective. Bigger picture, it's all normal in a bigger picture. So all these things that have been opposite, science and philosophy, it's all one thing. Actually, it's kind of, I guess, heartwarming in a way that it's the metaphysics that ends up deriving the physics, not the other way around. But it is all one thing. So that's kind of where we are. We've got these experiments pending. Whether they work out the way I think or not, I don't know. Nobody knows. That's why you have to do the experiment. In any case, I will learn a lot from the experiments and will be able to take the next step in progressing the theory. So they are necessary to continuing and going forward. So I'm anxious for them to be done and turn out however they turn out, because it's all going to be good. So that brings you up to date. It's giving you the people who really came here wondering, who is this guy? Really? Virtual reality? Seriously? Maybe you get a little idea about what it's about. So with that, let's just do, you want to take a break, don't you? Yeah. Vanessa needs a break.